Hello and welcome back to Precalculus 1. I guess week 3 or whatever. The topic for today is combining functions. And the first thing that I want to discuss is why combine functions at all? What is the meaning of combining the functions? And then we're going to do a few examples and then call it a day. Now, the first thing is we understand y equals f of x, and as example y equals 3x plus 1, and we can graph that. Something like this. I can't get it. I give up. Hey, proud. All right. It's going through 1. It has the slope 3. It's positive, so it goes up. So we understand notation of a function. We understand that the function is going to be that formula which has those conditions from the definition. And then also that there is a graph accompanying this. If we provide x value, we are able to compute the y value. So eventually, this 3x plus 1 is going to give you a number once you plug in a number for x. So if you want to compute f of 2, it's going to be 3 times 2 plus 1, and everything works out to be 7. So you see that the value of the function is 7. Awesome. Now, what I can do is I can have another function, g of x, and call that one x squared minus 2. Now I can compute g of negative 1. And that will be how much? Negative 1 squared minus 2, and the answer is negative 1 again. So we have this. So what I want to point out here is that the output gets to be a number. What can I do with output numbers? What can I do with 7 and negative 1? Yes. 7 and negative 1. Okay, that's for later. That's for actually next lesson. Can I add them? 7 and negative 1? Can I subtract them? Yeah, multiply, divide, all of that stuff. So, we are going to work on this thing today, where we understand that function at the end is just a number. And then because we can do operations on numbers, that implies that we can do operations on functions as well. So I'm going to start off with combining two functions through addition. I'm going to say that if I add f of x to g of x, I'm going to get in notation f plus g of x. Now, you have to observe algebraic rules, which means you are only able to add and subtract like terms. In terms of multiplication, you can multiply whatever, right, and do that stuff. But for the most part, you are observing algebra rules as you are doing this. So given that f of x is equal to 3x, what was it, plus 1, and g of x is x squared minus 1, if I am to add these two, I will simply put them on a pile, 3x plus 1 plus x squared minus 1, and get x squared plus 3x at the end, because plus 1 minus 1 cancel. Now, what does this mean? Well, if I'm to compute f of 2, I will get 7. If I'm to compute g of 2, I would get what? I will get, what's 2 squared?
4.
Minus 1 is
3.
3. Well, thank you. And how much is f plus g computed at 2? X squared, right? So that's going to be 2 squared plus 3 times 2 is 10. Do we see 7 plus 3 is 10? All right, so now I have to... They canceled in the arithmetic, right? Over here, in algebra.
Does that happen all the time?
Yes. And works for addition, subtraction, multiplication, division, squaring, all of it. So now we have a choice. Compute each function separately and then add the results, or combine functions first into a new algebraic expression and compute it then. They must give you the same answer at all times. Cool? Of course, cool, it's math. Now, all of this translates to graphing. If you graph these two functions on the same graph and you start adding their y values, the resulting new graph will be exactly the same as this one. Because each y value that you add, all the values pairs that you add together, this part will be the same as this one here. I can also subtract these two equations. So let's take a look at the same, but now f of x minus g of x, which can be denoted as f minus g of x. And now we have again f of x to be 3x plus 1 and the g of x to be x squared minus 1. And what else do we do? So now we already know that, well, we'll do that later. So how much is f minus g of x? Negative x squared plus 3x plus 2. Get rid of the parentheses. So we know that f of 2 from before is 7. G of 2 is 3. So 7 minus 3 is, anyone? Have your calculators out? Exactly. And how much is f minus g computed at 2? Yes, it must be. So negative 4 plus 6 plus 2 is also negative 4. So I hope you see that combining functions depends on your ability to do algebra. You're technically making a new function from old functions. Remember, this is a linear function. This is a quadratic U-shape, right? This is also U-shaped, but it looks completely different. So you have to observe that. Are you okay? Why did I put negative 4? It's a positive 4. Thank you. I will be right with you. What happens if I have two different x values? In that case, I cannot combine functions this way because this way depends on having always the same x value at one time. In that case, you have to compute them separately. So, oops. Come on, eraser.
Run out of ink.
You won't erase this one. Nah. Tough. Oh, no, there it goes. Okay. Let f of x be 2x plus 1 and g of x be absolute value of x minus 1. Graph f plus g of x. How would you go about doing this? Yes. You were volunteering. You like went above and beyond to get my attention. So, well, too late now. Yes. Yes. Wait, where is the time x?
That's where you put like a 2 or whatever. Then you plug it in for like 2 times.
Oh, you mean this x over here? No, that's not times x. That's in the definition of a function. You have instead of f of x, now you have f plus g of x. That's not, that's exactly where you would denote that you are plugging in 2 or 7 or some number.
Do we have to plug in our own number? Or like, you just want
No, you need to graph these. So how would you do this? Yeah, I think, yes.
Yes, you could just
It'll
put
be
it
annoying,
zero
but
and
yes.
you get y-axis.
Yep. Anyone else? Yes. That's what he said. And the answer is yes. Anything else? How do we graph? I said it. You graph both functions on the same coordinate plane, one over the other, and then you add their y values, point for point. Right? Let's take a look. Draw a bigger graph. And if you don't have a square notebook, well, it's not going to go that well for you. Too bad. Get a square notebook. 2x plus 1. So 2x, the slope is 2. So we get to draw the line through these points. That's a perfect line right there. And this is your f. Now g was x minus 1. So shifted 1 over. And we draw a 45. Now if you're not doing this precisely, obviously you're not going to get it. And this is the g. So now in red, I'm going to add their y components of some points and see what kind of graph happens there. So let's start at the y-axis, go to the right, and then we'll go back to the left. Yes? It's minus 1, right? Yes. Modification directly on x moves it left or right. If it was absolute x and then close absolute value and then minus 1, it will be going one down. Awesome. So observe that both y values are 1, only y. They both go through 1, so 1 plus 1 is 2. Then you have 0 and 3. Then you have 1 and so technically only 1 over. Then you have this height over here is 2 units. So go over here, 2 units up. This height over here is 3 units, so 3 units up. Go to the other side. You see that remember it's f plus g, right? So it goes here because f is 2 units and then take away 1. This one is 3 units, this one is 3 units, so that's going to be 0. Next point is here. Sorry, next is there, and then minus 1, 2, 3, 4. That one. Did this make any sense?
No.
Awesome. I get to talk about it. So what have I done? I simply added y values because those are numbers. This is, what I'm doing here is f plus g. So the y value for 0 is 1 for f and 1 for g. 1 plus 1 is 2. Are we all cool with that? 1 plus 1 is 2. Then I'm moving here on this x equals 1. For x equals 1, the y value for g is 0, and the y value for f is 3. 1, 2, 3. So the answer is 3. And that's why the red dot is there. Then we're going next one. For f, over here, f is 5. And this one is 1. 5 plus 1 is 6. So that's there, 6. You are simply adding y values. Y value of f plus y value of g. Later, you will be subtracting them, multiplying, dividing, squaring, whatever needs to be done. So only the y values, because x values are always given, right? You want to check it at 0, you want to add them for 1, add them for 2, add them for 3. And then you can see the pattern over here. This is f, and then you have to add this much on top. So I said add 2 squares. So this one's going to be 1, 2, 3, 4, 5, 6, 7, and then 2 is 9. And so on. So all I did is a simple addition. All I did was a simple addition of y values. Now to the left, we're getting into negative numbers. So here, I have f to be minus 1 on the y, and g to be positive 2. So they amount to positive 1. The next one, g is positive 3, f is negative 3, they cancel out. Right, so you're always adding these values. These are only y values that you're talking about. So y value for f, and at the same value, y for g. You can play with it and drop it in. Did it make sense now? Yeah. Right. Oh, did I mention welcome to Precalculus? Did I say that? All right. Here we go again. So let's focus at 1. Are you all with me?
Yeah.
We have f of x plus g of x is going to be f plus g of x. Now, the f plus g of x is going to be our red dots. So now, looking at the graph, how much is f of 1? How much is f of 1? Looking at our graph. Well, this is your f line. It's 3. Because at 1, the y value is 3. So this point over here is 1, 3. But we only need the y value. So f of 1 is 3. And how much is g of 1? 0. Because this point over here is 1, 0. Is this much clear for everyone?
Yep.
Is this much clear for everyone, not only 4 people? Yes. So you can all find, for x equals 1, the corresponding y values for both functions. And that's green for everyone. When you add these two values, what do you get?
3.
So that is going to be when you add the two functions. So that's the reason why the red point is at 3 again. Because we had f, and then we added 0 to it. So it ended up there. Now I'm going to move to 2. What's the function value for f function? 5. This point is 2, 5. So f of 2 is 5. How much is g of 2? 1. G of 2 is 1. Right here. So you're getting 2, 1. Right there.
I have a question. Isn't it better to plug every number in the formula?
Yeah, but you don't have the formula every time. Some of the homework problems are going to have, right, just 2 graphs. You will see when you start doing homework for 1/7. It's awesome.
I still don't get it, but I'm just using what they was and
But see, as I said, now you have the equations. You know that this line is 3x plus 1. When you get the homework, they're just going to put 2 functions on top of each other. Because having the graph sense is crucial. You will see that most of the work later on is not going to use, you know what, a lot of engineers say, yeah, I went through all that math, I'm not using any of it. It's a lie. Because by the time you're done with your training, which is your education to become an engineer, you see these graphs so much that you actually don't use equations almost at all. You read stuff from the graphs. When I went, I only took one electrical engineering graduate level course, and the professor walks in and says, the Fourier transform for blah, 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 blah is going to be blah, 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 and writes all these mathematical equations and said, but you know what, we can just shift it and then start talking about shifts. And just graphs. No calculations of any kind. So guys, understanding graph is much more important than actually knowing how to calculate anything. Because graph is the first thing you look at. Whether it goes up, whether it goes down, what is the energy doing, what is this speed doing, and so on. Looking at the graphs, how fast the market changes, right? All of these things are graph, 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 graph. So that's why we are forcing the graphs rather than calculations. So we are looking at x equals to 2 now. X equals to 2, g is 1, and f is 5. So how much is 1 plus 5? 6. 6 height is there for 2. When you go to 3, which is right here, you have this point, 3, 2. So that's we're going to have f of 3 and g of 3. G of 3 is 2, and f of 3 is 1, 2, 3, 4, 5, 6, 7. You add these two, it's 9. 1, 2, 3, 4, 5, 9. Now, when you get used to these things, you said, well, this is where f is. How much is g? Only 2 units above, so 2 units above. That's when you get used to these things. And you can quickly get it every time. Does it make sense now?
Yeah.
Wait, like I get all this, but why are we doing the red stuff?
We need to draw the graph for them now. Because the red dots graph is going to be graph for this.
I got it.
So you have 2 black graphs. One is for f, one is for g. And I'm going to draw the red line through the red dots. And that's going to be the graph of f plus g. So the red graph is f plus g graph.
So in like the homework where it's just going to give us 2 graphs,
Yeah.
just gonna,
They're not going to give you functions.
so we're going to do it that way.
Yes, you will be counting dots.
Would we be able to figure out the
Type of a function?
well, no.
Depends how good you are.
Figure out the equation from the graphs that they give us, or?
As I said, depends on how good you are. You might be able to. I remember that when stuff like this shows up on Calc1, theoretically don't even waste your time with it, because you just have the y values. You have to get used to the y values being the ones that you worry about. Maybe I can find, let me just see, they have to be in a textbook as well. This is the less interesting part of the lecture. The more important one is later. Second half. Awesome, I found it. Here it is. So I'm going to switch to the book. This is your standard. I can't make it any larger because in all their infinite wisdom, they never actually put a zoom button on this thing, so you can't make it larger. But see that? So these are actually 2 piecewise functions, right? 1, 2, 3, 4, 5 pieces for the red one. 1, 2, 3, 4 pieces for the blue one. And you shouldn't be messing with 9 different functions for no reason. So all you do is you look up the y values. They want to find f plus g at -3. You go at -3, which is here. F plus g, so one is 1, the other one is 4. 1 plus 4 is 5. Dot goes at 5. Done deal. Yes? Yes, because that's the output, right? When you say f plus g, it is y equals f of x, which is the reason why I started the lecture with reminding you that y equals f of x. So when you compute f of 2, you get y. When you compute f of 3, you get y. When you compute g of 2, you get y. G of 3, you get y. So technically, it's only the y value that you're adding and subtracting all the time, which is the reason why we have it this way. So those are the homework exercises, and as you can see, even when you go to your MyLabs Plus software, it's going to be the same. So now this one is actually cheap because you can figure out. Here's your, what's the equation for the blue line? You should be able to answer that like this. Absolute value of x plus 2. Nice. See? Like this. If you learn stuff, that should be a joke. That should be a joke to figure out. It's x plus 2, right? Because shifted 2 units to the left. Left shifts are plus 2 on x. Awesome. Great. So let's take a look. And all the other ones, multiplication, division, they all work the same way, except you will be subtracting or multiplying or dividing the y values from each of these. So now, before we start looking at the domains of these, we want to take a look at the combinations pass addition. So let's pick a homework problem. Here's problem 36. It says f of x is 6x squared minus x minus 1, and g of x is x minus 1. I will switch to the tablet so you see the two functions. So this is problem 36. They want the formula for f plus g of x. So that's part A. Part B, f minus g of x. Part C, f times g of x. And f over g of x. So what are the formulas for each of these when you combine them? So let's see how is the algebra. At this point, you should talk to people that are sitting or sleeping next to you. And check your work. Yeah, we can walk around. Yeah, we should. Oh, welcome back. Oh, just walk around, see. You don't have to practice, just need to find the equation.
Yeah, that's right.
How's it going?
Yeah.
I know. Well, when you see algebra, let me like write it down. Great part.
All right, let's take a look at all of these. Apparently, some of you are doing very well. Some of you are still confused. So let's get this. So this part, guys, is we take function f, which is 6x minus 1, and we add that one to g, which is x minus 1. You can put them in parentheses. Now we actually don't need these parentheses anymore, so we just get rid of the parentheses and we get 6x squared. And then minus x plus x, they cancel. And then minus 1 is minus 2. And that's the combination of the two functions. Next one. 6x squared minus x minus 1 minus x minus 1 is 6x squared, has no like term. Minus x is minus 2x. And then minus 1 plus 1, they cancel, and you have a 0. So that's the answer for the second one. The third one you get to FOIL. So now you should get 6 terms when you FOIL this. So you have 6x cubed minus 6x squared minus x squared plus x minus x plus 1. And then you combine like terms, and you get 6x cubed minus 7x squared, x's cancel, plus 1. And the last one is 6x squared minus x minus 1 divided by x minus 1. And then we do what? Divide, which is long division, right? From your intermediate algebra, we do the long division over here. And the long division is x minus 1 into 6x squared minus x minus 1. X into 6x squared goes 6x times, multiply it back, 6x squared minus 6x, subtract, first one drops, 5x minus 1, x goes to 5x plus 5 times, multiply it back, 5x minus 5, and that's going to be plus, so remainder 4, plus 4 over x minus 1. If you forgot how to do this from intermediate algebra, there's about 60,000 YouTube videos on it. And it's going to be awesome 2 days. Guys, we are going to use this long division of polynomials a lot in chapter 2. A lot. So we're going to have 2 sections in chapter 2 where we're just going to do long division. Exclusively. Every single problem. So you got to go and review that stuff while it's still kind of walk in the park portion. So there's our answer. So we have this as the answer, this as the answer, this as the answer, and this is the answer. Now, we get to discuss domain of each of these.
Yeah.
What is the domain when you combine 2 functions? Great. Let's think about this. So what is the domain for our polynomials? That question can be translated into a statement: what is the set of all possible numbers that I am allowed to plug in a polynomial when I'm computing it? So what kind of number can I plug for x, for f? Any number. From negative infinity to positive infinity, whether it's rational or irrational, it doesn't matter. We can plug any number under the sun into a polynomial and we will get the answer on the other end. So, what would be the domain for this? We say all real numbers, right? Domain for this, all real numbers. So if you are able to plug all real numbers there and there, then you should be able to plug all real numbers in its combination. Sure, if it's addition, multiplication, and subtraction. But look at the division. On its own, f and g can plug all the real numbers. As soon as I combine them, what happens? Yeah. G gets the restriction. You're not allowed to use 1. Right? So, division ones will probably give you, I can rig it so it's not like x squared plus 1. That can never be 0. So, cool, right? But x minus 1 can be 0 if x is 1. So when you combine two functions, you can have them start with both of them having all real numbers in the domain. But when you combine them, because x minus 1 is the denominator, and we are not allowed to have zeros in the denominator, that immediately eliminates that x minus 1, x is 1. So, for the first three, a, b, c, both input functions are all real numbers, and the answer has the domain as all real numbers. But for part D, both input functions again are all real numbers, but the domain for the combined function at the end is all real numbers except 1. So you can go negative infinity up to 1, union 1 to positive infinity. So domains, I will start like this. Domain for f, all real numbers. Domain for g, all near numbers, and that's because they're polynomials. Polynomials have all real numbers in the domain. Now, f plus g, again, all real numbers. F minus g, again, all real numbers. F times g, again, all real numbers, because you're getting polynomials everywhere. And then, here, in blood, f over g from negative infinity to 1, union 1 to infinity, because x cannot be 1, no zeros in the denominator allowed. Fair? Let's take a look at a different type of example, because all of these contained polynomials. Let's see what Mr. Blitzer has for the rest of us. Oh, he has some very, very interesting problems. Give me a problem between 40 and 50.
47.
47? Are you sure?
Yeah.
Here we go. F of x is given as square root of x plus 4. G of x is equal to square root of x minus 1. And we want everything again. We want the function compositions, and we want all the domains. Sorry, function combinations, not function combinations. So A, I want to know what's f plus g of x, and then later I want to know the domain. B, f minus g of x, I want to know the domain. C, fg, I want to know the domain. D, f over g of x, I want to know the domain. Right? No pressure, you have 19 seconds.
No.
So with this problem, we're going to see how much analysis is actually required in certain pre-calculus 1 problems. Previous one, not a problem at all because we had polynomials, right? They combine straightforward and their domains are relatively simple because it's all real numbers. You only worry if the stuff is in the denominator. But now we have square roots. What is the domain of that thing? Right? The domain of square root of x. Just plain vanilla square root of x. What's the domain of that thing? 0 to positive infinity. Now how about square root of x plus 4? From negative 4 to positive infinity. See? So we have to be careful with the domain. Combining these functions obviously depends on your knowledge of algebra and the things you are or not allowed to do. Oh, okay. For the moment, what the hell happened to the phone?
Oh. Thanks for watching.
Okay, so let's start. Part A. I have f of x is x plus 4 plus square root of x minus 1. There are no mathematical rules for us to combine this. The only way to add square roots is if they have identical arguments. Argument is whatever is under the square root. Well, one has x plus 4, the other one has x minus 1. So we can't combine this algebraically in any way. So this is done in terms of the first part. Now, how do we find the domain? Well, first I need domains of f and domains of g separately. So we already said that the domain of square root of x, so if you have y equals square root of x, domain for that thing is 0 included to positive infinity. Why? Because you know how the graph looks like, because you memorized that, right? We talked about it. Graph looks like that. It has this dot at 0, 0, which means that value is defined. And hell, you know the square root of 0 is 0, so that's cool. So as you are looking for domain, swiping from negative infinity towards positive infinity, no function, no function, no function, it starts at 0, including and then function exists forever towards positive infinity. So, infinity. Now, what is the domain for x plus 4? Well, what is the plus 4 doing? This is how you connect all sections together. It moves it where? To the left 4 units. So the graph looks like this now. Whee! So what's the domain for this thing? -4 to positive infinity. Just make sure you're putting brackets and parentheses properly. So we have that domain for f is included -4, excluding positive infinity. And what's the domain for the other one? +1 to positive infinity. Awesome. So now, what is the domain for our function here? What do you think? The two together. But how do you combine the two together? You can't do the union. Why would you say 1 to positive infinity? Brilliant. The answer is 1 to positive infinity. Why? Because that's the one that is more restrictive. Observe. If you pick 7, 7 plus 4 is 11, you can take square root of that. 7 minus 1 is 6, you can take square root of that. So if you pick number 7, all cool. If you pick number, let's say 0, which works for G, sorry, for F, 0 plus 4 is 4, you can take the square root. But look, 0 minus 1, right? You get your -1 here. So when you combine these, you look for the more restrictive domain. Now I have an analogy for you to understand. Picture yourself trying to catch the train, which is slowly moving out of station but the doors are still open. If you run, you will catch it. But your grandmother is with you. Right? You ain't gonna catch it. Or, right? Or you might, I don't know. So you get the idea. The more restrictive domain wins because that one is guaranteed for both, right? So as I said, everything that is here works there, but these numbers from -4 to 1 do not work here. In that case, this one is more restrictive. So that works also for subtraction. For subtraction, same rules as for addition. We can't combine these in any way. So, x plus 4 minus square root of x minus 1, and domain is the same thing, 1 to positive infinity. Now we get to multiplication. If you are remembering the formula from algebra, and you should, that square root of a times square root of b is the square root of ab, you will quickly come to this. And what happens with this stuff is you can FOIL, right? Combine like terms, and get square root of x squared plus 3x minus 4. But now we have to discuss the domain for this. And discussing domain for this, bit of an issue, right? You are not allowed to plug in any negative values into under the square root. And you are supposed to plug in all of the positive ones. So, so what's the domain? Domain is going to be when x squared plus 3x minus 4 is larger than 0, it's going to be okay. And when x squared plus 3x, well, equal, and minus 4 is less than 0, that's going to be no bueno. Does this make any sense? So I'm going to highlight here and say all of this represents a number. Plug in x equals to 1. 1 plus 3 is 4 minus 4 is 0. It works. Awesome. Plug in 10. 100 plus 30 is 130 minus 4 is 126. Works, right? So now we have to figure out what are all the values that will give us positive values under the square root. Now we can do that by examining factors of this, and we know the factors x plus 4 and x minus 1. And we just need to know when is this larger or smaller than 0. We can set up a table. X plus 4, x minus 1. We know what the values are that we are looking for, which is negative 4 and positive 1. Those are the ones that make everything 0. So now, let's think about this. If you pick a value that is in between negative infinity and negative 4, you might pick negative 5. Negative 5 will give you a negative value here, and it will give you a negative value here as well. Negative 5 plus 4 is negative 1. Negative 5 minus 1 is negative 6. They're both negative values. Negative times negative is positive. So this is a cool region because negative times negative is a positive. Awesome. So anything that is in between negative infinity and negative 4, including negative 4, because that gives a 0, it's okay, is okay for the domain. Perfect. Then we go in the next bracket. And the next bracket we pick 0, because we can. That's between negative 4 and 1. Pick any number. Plug it in. 0 plus 4 is positive, and 0 minus 1 is negative. And what's positive times negative? That one turned out to be negative, not good. Pick number bigger than 1. 2. Plug 2 in the equation, you get 6, which is positive. Plug 2, 2 minus 1 is 0, so it's positive. What's positive times positive? So, that's also cool. So what's the domain? Negative infinity to negative 4, union 1 to infinity. Welcome to Precalculus 1. It's called analysis. So I will explain this chart one more time because you might be confused by it. So what do I have? I am supposed to find all of the numbers that I am allowed to plug in these equations so that they give me positive values. Why do I want positive values? Because they're under square root. They're under square root. That means that I will be able to take the square root of those values. So, when you factor this, the zeros of the problem, right, are at negative 4 and 1. So we have a test point between negative infinity and negative 4. You pick any number. You can do it with negative 1076 if you want to. But you can do it also with negative 5. So negative 5 gives you negative 1, which is a negative value. Negative 5 minus 1, negative 6, so again negative value. Negative times negative, we're multiplying. Negative times negative is positive, and we can have positive under the root, so that whole region of numbers is cool. Now, if you didn't like -5, try with -9. -9 gives you a -5 and a -10, both negative, multiply them positive, so cool. Hop in the middle region, pick a number between -4 and 1, which is 0, say, but you can go with -1 or -3/2 if you like pain. And then you put 0 here. 0 plus 4 is 4. So that's positive. That's okay for the root. -1. So 0 minus 1 is -1. Positive times negative is negative, and that's not cool for under the root. So we X out region -4 to 1. And then picking a number between 1 and infinity, you pick 2, you can pick 10, right? You can pick pi squared, whatever. And once you have that, that's going to be 2 plus 4 is 6. That's a positive number, cool for under the root. 2 minus 1 is 1, cool for under the root. Positive times positive is positive. So what we have, again, a region of numbers that are okay to be used. That's part C. Let's go with part D. We are dividing square root of x plus 4 by the square root of x minus 1, which we can write under the single square root, x plus 4 over x minus 1. And we are wondering what the domain is now. Well, the two domains for addition and subtraction are the same. So for multiplication and division, they should be the same, or about the same. It's going to use the same idea with the same chart. Are there going to be any differences? Yes, no? No? Yeah, you can't keep 1 anymore. Why? Can't have 0 in denominator. So Control C, Control V on domain, and then just exclude 1. And maybe you want to point to that parenthesis with the arrow and write cannot have 0 in the denominator. Then there we go. Perfect. Yes. What happened? I can't hear you. Oh, something similar, not this one, but something very similar, yeah. So good pick, 47. Yeah. B. What? 40 minutes?
1, 2, 3, 4.
So we'll have to continue this lecture next class because the most important part we didn't get to. Maybe we can do one more of these now. We have 4 minutes. Yep.
Not that much.
42. All right, so this one now has a rational function in. What's the domain for the first one? I can't hear. You said something. What was it?
Well, everything but 0.
Everything but 0. So negative infinity to 0, union 0 to infinity, domain for the first one. How about domain for the second one? Same thing. So both of these have absolutely same domains. Now let's add them, see what happens. F plus g. If I add these, I get 6 minus 1 over x plus 1 over x, and then what happens? Uh-huh. It's just a 6. What's the domain for that? Y equals 6. What's the domain? All real numbers. So how does that look like? What's the graph of y equals 6? Does anyone know?
Yeah.
Straight line across 6, yeah. Y equals 6 is a horizontal line like this through 6. Do you see that it's all real numbers from negative infinity to positive infinity? Right? So for that function, yeah, we're good there. Now how about f minus g? Anyone? F minus g? You have common denominator, minus 1 is minus 2. How about the domain? Very good. All real numbers except 0. How about f times g? What's the domain there? Again the same. All real numbers except 0. Because 0 is not included in any of the two parentheses. And now f divided by g. Does this bring back memories from intermediate algebra if you took it? You remember that one section where no one likes? There it is. So we multiply by x top and bottom. To simplify it, we get 6x minus 1 divided by 1. Domain? Yeah. What an awesome problem, right? Much easier than the square root problem. So officially, welcome to Precalculus 1. It's going to be like this. I will continue this lecture, so there is still a second half, something that is extremely important, which is function composition. It will never leave you. So we'll continue this next class.